Okay, lesson 66, formula for systems of equations, phase shifts and period changes. Okay, the first part, finding a formula for systems of equations, I don't really think this is very important, but I'm going to do it anyway because your book has you do it and it will be in your problem set. Instead of doing this problem the traditional way, you can do it so that you can develop a formula where you can just put your coefficients into the formula and get your values for x and y. So, I guess this could be helpful if you had a whole bunch of these systems of two equations to solve, and you could just plug your numbers into a formula instead of doing substitution and elimination. So let's solve this one let's get ourselves a formula. So that's why it's called formula for systems of equations. What we want to do is make some abstract coefficients. So instead of using 3, we're going to use a sub 1. We'll leave the x in there. Instead of using 2, we'll use b sub 1. Leave the y in there. And that's going to equal c sub 1. So we're taking out all the numbers and replacing with abstract variables. So then we're going to have, instead of the 4, we're going to have a sub 2. Instead of the 5, we're going to have b sub 2. You get in the picture of this. Instead of the 3, we'll do c sub 2. Now we're going to solve it by elimination. We're going to solve for the x first, so we're going to eliminate the y's. And I wrote a y instead of a 2 here. Hold on a second. My house is quite distracting right now. People are making lunch. Okay. So in order to eliminate the y's, we're going to have to multiply the first equation by a b2. And we're going to multiply the second equation by a negative b1. And when we distribute that through, we're going to get a sub 1, b sub 2, x, plus b sub 1, b sub 2, y, equals b sub 2, c. I'm only going to do this for one variable, and then we're just going to solve for the x's, and then you could do the y's by yourself. I'll give you the formula. So we distribute this one through, we're going to get negative a sub 2, b sub 1, x, minus b sub 1, b sub 2, y, equals negative b sub 1, c sub 2. And you can see we did elimination the old elimination way. So if we add these y's together, they're going to cancel out, and we're not going to have any y's. And if we add the x's together, they're not like terms, so we can't just say 2, a sub 1, b sub 2. We have to say, if we add these together, I'm going to get on here. It's going to be a sub 1, b sub 2, x, minus a sub 2, b sub 1, x. So I added these together. They're not like terms, so I can't combine them. And then on the right side, we just get b sub 2, c sub 1, minus b sub 1, c sub 2. And then our whole goal here is to solve for x. So we'd factor out an x from this. A sub 1, b sub 2, minus a sub 2, b sub 1, equals b sub 2, c sub 1, minus b sub 1, c sub 2. And then we just divide both sides by a sub 1, b sub 2, minus a sub 2, b sub 1. Now, you're saying, what's the point of that? Well, now we have x equals this formula right here. So, we can do the problem if we have what x is, and if we do the same thing for y, and we get y equals a sub 1, c sub 2. We would eliminate the x's this time, minus a sub 2, c sub 1, all over a sub 1, b sub 1, minus a sub 2, b sub 1. So we would use these two formulas to get our x and y values. So again, the problem got pushed away at the top. So it's 3x plus 2y equals 8, and 4x plus 5y equals 3. So we would substitute our a sub 1 is 3, our b sub 1 is 2, our c sub 1 is 8, our a sub 2 is 4, 4, our b sub 2 is 5, and our c sub 2 is 3. So if we have this formula, we can just plug these values into these equations and we'll get our answer out. So let's just do that real quick. So we get x equals, we're going to do the x one, we're going to get 5 times 8, because that's our a sub 1, b sub 2. So we're up in this one. B sub 2 is 5, c sub 1 is 8. So I'm just going to put these in real fast. 5 times 8 minus 2 times 3. This is just purely substitution, all over 3 times 5 minus 4 times 2. And if we multiply that all out, we're going to get 34 over 7. And if we do the same thing for our y, we would substitute a sub 1, which would be 3, times c sub 2, which is 3, etc., etc. And we're going to get 3 times 3 minus 4 times 8 all over 3 times 5 minus 4 times 2. And if we multiply all that out, we're going to get negative 23 over 7. And you can kind of see, like if you had a whole bunch of these systems of equations right here, if you had a whole bunch of these, it would be kind of nice just to plug them in and get your x and y values out. You can also do this with systems of 3 equations, but it's going to be a lot harder. But if you come up with a formula, you could have a computer program. If you had this formula, the computer program will take care of you could just spit out the numbers if you have them solved for x and y. So that's it for that. Now we're going to do some sine and cosine curves. And I know you guys have had trouble with these, so I'm hoping you're watching this video right now and we can get rid of your troubles. Okay, this is example 2, and first we're going to talk about it before we do it. This is the formula that we use to do the sine curve, looking at a graph. So our cosine curve would be y equals a plus b cosine of c theta plus d. If you can figure out what a, b, c, and d are, all you have to do is substitute it in and you get your equation. So a is the center line. So let's look at this one up here. If we look, we can find the center line. Remember how to find it? You just find the distance between these two, which would be 8, and you divide it by 2, so it would be 4. So we go 4 from the 7, 6, 5, 4, and it would end up being 3. So our amplitude, our center line, is 3. So this right here would be 3. That's our center line. Then our amplitude, so that's our A. A is 3. Then our amplitude is the distance from the center line to the peak of our curve. So you can see the center line, if this is center line is 3 and we're going to 7, this distance, our amplitude, which is B, and our formula down here is 4. So just start with your center line, then do your amplitude, and then we'll do the harder things. Okay, that's the first two things, center line, amplitude. The next thing is you're going to determine C. So C goes after the sine. C would be whatever 360 degrees divided by the period. So that's how stretched out your curve is. So we have to figure out, it's always going to be 360 degrees, and to figure out your period, you go from peak to peak, or you can go from where it crosses to where it crosses. So let's figure that out. Let's just go from where it crosses to where it crosses and see how many degrees it is. So here's where it crosses at negative 225, and the next place where the graph starts repeating again is at 315. So if I'm going to go from 225 to 315, it's going to be 225 this way, and then we're going to add a 315. So we're going to add 225 plus 315. and we're going to get 540. So that's going to be our C. Our C is 500, actually, that's not it. It's going to be 360 divided by 540. That is going to be our C value. And if we divide that, we're going to get a fraction. It's going to be 2/3. So our C is going to be 2/3. So far we have our A is the center line. Our B is our amplitude. Our C is always 360 divided by from crossing to where it starts a new one, where it starts a new curve. And if it's in radians, it's going to be 2 pi over the period in radians. So you can just convert those to degrees. So we have our C, and now all we need is our D. Our D is how much it shifts. Now, the shift is for sine, it's where it crosses the center line, where it initially started crossing the line. Our normal sine curve would start there. How much did it shift? Well, it's from where it crosses the center line to where it now crosses the center line. So it's shifting 45 degrees. Now if it goes to the right, we subtract it. So for our sine curve, our D is going to be 45 degrees. For our cosine curve, listen carefully, our cosine curve is where the peak moves to. So in our cosine curve, it started out at 0, and it's shifting to the left over to here, so it's shifting a negative 90 degrees. So this is your sine, is where it crosses the center line, and your cosine is where the maximum, where it moves to. So now we have all our information, we can write our equation, and that will be it for how you do these. So here we go. So we'll do our sine curve and our cosine. We'll do our sine curve in red. So our sine equation will be y equals A is your center line, B is your amplitude, sine, C is your how much it's stretched out, which would be 2/3. Now just keep in mind you go from crossing to crossing, figure out how many degrees that is, and divide that into 360. So that would be 2/3. This is x, so instead of writing theta, we would just write x. And for the sine curve, it's shifted to the right 45, so we subtract 45. And that would be the equation of this sine curve. Now let's do the cosine curve. Let's do that in blue. So we have y, everything's going to be the same. We have 3 for a while here, 4, then we'd write cosine. Because your center line's 3, your amplitude stays 4, your stretch stays 2/3. The only thing different is it's moving to the left 90. The peak is moving to the left from where it would have started. It's moving to the left 90, so it's going to be x plus 90. And you'll put your degrees on that. And that is a step-by-step on how to write an equation of a sine and cosine curve. So give that a try. If you have any trouble with that, please put it on help board. Okay, that's it for lesson 66.